Lesson 1.1, Number Patterns. Let's read the directions. Find the sum, then use the commutative property of addition to write the related addition sentence. So let's see if we have any keywords that's going to help us solve the problem in the directions. So I see one right here, sum. Now the word sum means the answer to an addition problem. So whenever we see the word sum, we know we're adding. So I'm going to put a plus sign. Now, commutative property. Commutative property means the numbers switch. So I'm going to write switch. So the sum means the answer to an addition problem, and the commutative property means switching the numbers. So let's begin. Number one. 9 plus 2 equals 11. So that must mean 2 plus 9 also equals 11. So we found the sum of 9 plus 2. 9 plus 2, the sum was 11. So with the commutative property now, we switch the numbers. So now it's 2 plus 9 instead of 9 plus 2. So if 9 plus 2 equals 11, that means when we switch the numbers, 2 plus 9 will also equal 11. Let's look at number 2. First step says find the sum. 4 plus 7. 4 plus 7 will equal 11. Now we have to write the related addition sentence at the bottom. So if 4 plus 7 equals 11, so now when we switch the numbers, when we switch the 4 and the 7, it should also equal 11. So let's see. 7 plus 4, and that's right. It also equals 11. On to number 3. 3 plus 10. 3 plus 10 we know will equal 13. So if 3 plus 10 equals 13, when we switch the add-ins, the 3 and the 10, it becomes 10 plus 3. So 10 plus 3 equals, that's right, 13. Because all we did was switch the add-ins. So we have the same sum, 13 and 13. On to number 4. 6 plus 7. 6 plus 7 will equal 13. So now we found a sum of 6 and 7. So now with the commutative property, we switch to 6 and 7. So now it becomes 7 plus 6. All we did was switch these two numbers. So now 7 plus 6 will also equal 13. All we did was switch the order. We found a sum, then we switched the order. On to number 5. 8 plus 9. 8 plus 9 equals 17. So that must mean with the commutative property, the new related addition sentence will be 9 plus 8, and that will also equal 17. On to number 6. We have 0 plus 4. 0 plus 4 will equal 4. Now, with the commutative property, we switch them for to get the related addition sentence. So that must means it becomes 4 plus 0. But since it's the commutative property, so if 0 plus 4 equals 4, then when we switch the numbers, 4 plus 0 will also equal 4. On to number 7. First thing we're going to do is read the directions. Is the sum even or odd? Then they're asking us to write even or odd. So again, let's find any keywords. Again, we have sum, which means to add the answer to an addition problem. So we know we're going to be adding. And also even and odd. Now we know that even numbers, before we can do these problems, we must know what even and odd mean. Even numbers end in either 0, 2, 4, 6, 8, and odd numbers end in 1, 3, 5, 7, 9. So if it ends in a 0, 2, 4, 6, or 8, it is even. And if it ends in either 1, 3, 5, 7, 9, it is odd. All right, so let's begin with number 7. 5, of course, we have to find the sum first. 5 plus 2. 5 plus 2 equals 7. Now, we have to write whether 7 is even or odd. Now, we already said that if it ends in 1, 3, 5, 7, 9, it's odd. And that's exactly where number 7 is at. So number 7 is odd. Let's look at number 8. 6 plus 4. So let's find the sum. 6 plus 4 equals 10. Now, there we have two numbers now, but we have to find to see if a number is even or odd, we have to look at the last number. The last number is 0. Now, if it ends in 0, it is even. We always look at the last number, the number at the end. So this had two numbers, 10 has two numbers. Since it ends in 0, that's the number we use to find if it's even or odd. So 10 is even because it ends with 0. Now let's look at number 9. 1 plus 0. 1 plus 0 equals 1. That's only one digit. Now we know if it ends in 1, 3, 5, 7, 9, it is odd. So therefore, number 1 is odd. Number 10. 5 plus 5. 5 plus 5 is equal to 10. But to find if it's odd or even, we have to look at the last number. The last number is 0. So that must mean 10 is even. We focus on the number at the end. Now let's look at number 11. 3 plus 8. 3 plus 8 is 11. Now we have to find out if it's even or odd by looking at the last number. So I underline the last number. The last number is 1. So that means 11 is an odd number. Now we have number 12. 7 plus 7. 7 plus 7 is 14. There we have two digits, two numbers there, but we only focus on the end number, the number at the end. Since 4 is at the end, it is even because any number that ends in 0, 2, 4, 6, or 8 is an even number. Now let's do the problem solving questions. Number 13. Ada writes 10 plus 8 equals 18 on the board. Maria wants to use the commutative property of addition to rewrite Ada's addition sentence. What number sentence should Maria write? Let's read this to see if we have anything important that we can use to solve the problem. Let's find out if we have any important numbers or keywords. And we always underline the question because the question tells us what to find. So the first thing is, we're going to underline 10 plus 8 equals 18. Now, Maria wants to use the commutative property. So, we have to underline the commutative property because that's important. To rewrite Ada's addition sentence. So we have to rewrite Ada's addition sentence using the commutative property. Now the question which tells us what to do, what number sentence should Maria write? Okay, so since we have 10 plus 8 equals 18, we have to rewrite it as 8 plus 10 oops 8 plus 10 equals 18. So all we did was switch the numbers 10 and 8. We switched those two numbers and we got 18 because all we did was switch the numbers. So 8 plus 10 equals 18. Now number 14 says, Jackson says he has an odd number of model cars. He has 6 cars on one shelf and 8 cars on another shelf. Is Jackson correct? Explain. Okay, let's find out all the important information. So Jackson says he has an odd number. Odd number is important. Since it's an odd number, we know it has to end in 1, 3, 5, 7, 9. So he has an odd number of model cars. Now he has 6 cars. So he has 6 cars. I'm going to circle 6 cars. That's an important number. On one shelf and 8 cars on another shelf. Now let's see if he's correct. So he says he has an odd number. So let's add the cars on both of the shelves to see if we get an odd number. So we have 8 plus 6. 8 plus 6 equals 14. So we solve for 8 plus 6. So we had 6 cars on one shelf and 8 cars on another shelf. Let's see if that equals an odd number by looking at the last number, the number at the end. So the number at the end is 4. 4 does 4 is not an odd number. 4 is an even number because any number 14 is an even number because any number that ends in either 0, 2, 4, 6, or 8 is all even. So that means Jackson is incorrect. Incorrect. Oops, let me fix this. Jackson is incorrect. So Jackson was wrong. He has 14 toy cars in total. So 14 is an even number, not an odd number. Okay, number 15. Number 15 says, write the definitions of the identity property of addition and the commutative property of addition. So we're going to write the definitions for the identity property of addition and the commutative property of addition. So the identity property states that any number plus 0 equals that number. So an example of that would be 7 plus 0 equals 7. And that's the identity property. Again, any number plus 0 will equal that number. So if it's 2 plus 0, the answer will be 2. If it's 7 plus 0, the answer will be 7. So now we have one of the definitions. Now we have to find a definition of the commutative property. So the commutative property is when you add two or more numbers. So the commutative property states that you can add two or more numbers in any order and get the same sum. So what that means is, here's an example. 3 plus 4 equal 7. And 4 plus 3 will also equal 7. So we have two numbers, 3 and 4, 4 and 3. Now, when we switch the numbers, we still get 7. And that is the commutative property. All right, so let's flip to the back page. Before we flip to the back page, just remember the identity property involves the number 0. Whenever you hear the identity property, you know it's going to involve the number 0. And the commutative property, the keyword to remember is that the numbers switch. The numbers we're adding switch. And when we switch the numbers, we still get the same sum. Okay, so let's go to the next page. Everybody on page 10. Number 1. Marvella writes the addition problem 5 plus 6. Is this sum even or odd? So let's see. Marvella writes the addition problem 5 plus 6. Is this sum even or odd? Now we know the word sum is the answer to an addition problem. So let's solve 5 plus 6. 5 plus 6 equals 11. Now we have to find, is 11 even or odd? Now we already know even numbers end in 0, 2, 4, 6, or 8, and odd numbers end in 1, 3, 5, 7, 9. So let's look at the number at the end. The number at the end is a 1. So that means number 11 is an odd number. Okay, let's look at number 2. What related number sentence shows the commutative property of addition? So we have to write a related number sentence that shows the commutative property of addition. Number 1. Marvella writes the addition problem 5 plus 6. Is this sum even or odd? So let's look at the problem to see if we have any keywords, and we're going to underline the question because the question always tells us what to do. So we have 5 plus 6. We're going to circle that. we have, that's an important number, so that's why we're circling 5 and 6. We have the word sum. We're going to circle that. We know that the word sum means the answer to an addition problem. So whenever we have the word sum, we know we're going to be adding. And also we have even or odd. We know even numbers end in 0, 2, 4, 6, 8. And we know that odd numbers end in 1, 3, 5, 7, 9. So let's begin by adding 5 plus 6. We know 5 plus 6 is going to equal 11. So we found the sum. The sum of 5 plus 6 is 11. Now we have to find whether the sum is even or odd. Now we look at the number in the back. Now the number in the back is 1. So we know if the number ends with 1, 3, 5, 7, 9, it is odd. So that means number 11 is odd because it ended with the number 1, and the number 1 is an odd number. Number 2, what related number sentence shows the commutative property of addition? We have to find a number sentence that shows the commutative property of addition. So 3 plus 9 equals 12. Since we're using the commutative property, we're going to circle the keyword commutative property. Now we know that the commutative property means to switch the two numbers that we are adding. And the two numbers we're adding are 3 and 9. So we switch the order. So 3 and 9 becomes 9 plus 3. All I did was switch the numbers. So if 3 plus 9 equals 12, that must mean 9 plus 3 also equals 12. On to number 3. Amber has 2 quarters, 1 dime, and 3 pennies. How much money does Amber have? So let's look at the problem. So she has 2 quarters, 2 quarters, 1 dime, and 3 pennies. Now we underline the question because the question tells us what to do. How much money does Amber have? So we know that she has 2 quarters, 1 dime, and 3 pennies. We have to find the value of the quarters. We know that 1 quarter is equal to 25 cents. So she has 2 of those. So 25 for the first quarter and 25 for the second quarter. Now we add these numbers up to see how many quarters she have in total. So 5 plus 5 equals 10. We carry our 1. Now 1 plus 2 equals 3. 3 plus 2 equals 5. So she has 50 cents in quarters. 2 quarters equals 50 cents. Now she has 1 dime. We know that 1 dime equals 10 cents. So if we add the dime to the amount of pennies she has 3 pennies. So she has 1 dime equals 10 cents, and she has 3 pennies, and each penny equals 1 cent. So she has a total of 3 cents. So now let's add the dimes and the pennies together. 10 plus 3, 0 plus 3 equals 3. And then 1, we just bring it down. So 10 plus 3 equals 13. Now, to get the total amount that she has, we have to add the 2 quarters plus the dime and the 3 pennies. So we add the 50 plus the 13. 50 plus 13. 50 plus 13, let's start adding from the ones place. 0 plus 3 equals 3. 5 plus 1 equals 6. So how much money does she have? Amber has Amber has 63 cents. She has 63 cents. That is our answer. And we got our answer by adding the 2 quarters. The 2 quarters, each quarter is 25 cents. Since we had 2, that's 25 plus 25. That gave us 50. Now she had 1 dime. So we have 1 dime equals 10 cents. And she had 3 pennies. Each penny is 1 cent. Since she had 3, that's a total of 3 cents. So we added the 1 dime plus the 3 pennies, we got 13. Now we put the total together, the 50 plus the 13, right here, the 50 plus the 13, and we got 63. 63 cents. Now, number 4. Josh estimates the height of his desk. What is a reasonable estimate? So let's see. We have a word over here. Now, what is a reasonable estimate? So, an estimate is a guess. It's not the exact number. So, we want to figure out what is the height of his desk. So, a reasonable height for a desk would be about 2 feet. So, we can write 2 feet. On to number 5. Number 5. Use the bar graph for numbers 5 through 6. Let's look at the bar graph. Books read at the top and the number of books read at the side. So we had Juan read 6 books, Bob read 2 books, Maria read 4 books, Alicia read 5 books. Okay, so we're going to write 6 for Juan, 2 for Bob, 4 for Maria, 5 for Alicia. Now, number 5 says, who read the most books? So let's look at the bars and see who had the longest bar. Juan had the longest bar, and it ends at the number 6. So we know that Juan read 6 books. So he read the most book, Juan. So we're going to write Juan as the answer, and let's put comma 6 books. And let's check if our answer is correct. Juan read 6, Bob read 2, Maria read 4, Alicia read 5. Juan had the highest number, the biggest number, the longest bar. Now let's look at number 6. Who read 3 more books than Bob? Who read 3 more books than Bob? So we circled and underlined what we found was important. So who read 3 more books than Bob? So let's find Bob on the bar graph. Bob is right here. Bob read 2 books. But we have to find out who read 3 more books than Bob. So we have 2, 3 more would be 1, 2, 3. So we have to find a person that read 3 more than Bob. So who read 5 books? Not Juan. Juan read 6. Not Maria. Maria read 4. Alicia, let's check if it's Alicia. 1, 2, 3, 4, 5. It is Alicia. Alicia read 3 more books than Bob. So we're going to write Alicia, and we're going to put 5. And we are done until the next lesson. Round to the nearest 10 or 100.